Good morning, everyone. Susan and Lorna, is my audio okay? Can I just check yours as well?
I can hear
Absolutely
you.
fine.
Oh, perfect. All of us at once. Perfect. Thank you both so much. Good morning, everyone. Thank you for joining us this morning for Learning to Code with CodeClub, and we're looking at moving on to Python from scratch. My name is Jenny Mackay. I'm one of the Digital Skills Development Officers. I'm also joined by Susan Say, who's another colleague of mine from Education Scotland, and we've got Dr. Lorna Gibson, who is the CodeClub Programme Manager and CodeClub Guru, and she is going to take you through the hands-on demo today. Okay, so what we're going to look at is a little overview very briefly around computing science within the technologies curriculum and how the CodeClub resources can fit into that and the applications that they can be used with. We're also going to give you, or Lorna's going to talk you through an overview of CodeClub itself, what it is and how you can engage with it. It's free, open source, there's no cost attached, and we'll talk you through all of that. We're also then going to look at using Python projects, so the range that are available to you that are scaffolded for you to use, and how these interact with computing science skills. We'll then give you an introduction to a Python project, and then I'll talk about help and support. So, within the technologies curriculum, hopefully you're all aware that they were updated a few years ago, and we now have a much wider, deeper range of computing science experiences and outcomes from early level right through to fourth level. Computing science is fundamental, along with computational thinking at early level right through. There's a range of ways it can be applied, and there's a breadth of resources available to you all, and we're going to touch on some of them today. Python, for those of you who are maybe looking at it, so you may have started with computational thinking and maybe programmable devices like bbots within early level and moved on to using Scratch Junior or Scratch in first level and second level. So Python probably fits in around second level onwards, but again, you know your young people and you know when they're ready for their next step and next challenge. And it's starting to move away from that block-based coding that we'll look at in a second into lines of script. It's a really easy way for them to be able to still link back with the colours that they may be familiar with to categorise the application, the control that a piece of code does. And it's also a nice way that you can start to link out into maybe projects that have a physical resource as well, where they can start linking it to maybe making resources as well. So as I say, for computing science, you may have started with programmable directional toys and objects, so bbots, bluebots. There's a range of products available, or even codepillars and such. And then from there, you would probably have moved on to block-based coding or visual coding, which is programs like Scratch, Maker Code from Microsoft, and lots of the programs available for microbits as well. But what we're looking at today is that next step. So this is what, for those of you who are new to Python and who've maybe not seen any of their projects before, this is what Python looks like when it's programmed. You can see it still has an output. So again, the familiar setup where we have a screen at the side for those younger users who are maybe used to Scratch, and this is a next step for them. You can see what I was referring to earlier about the color coding. So again, there's still things that link back. It still makes it really clear. So when they're maybe doing something and they're trying to debug it, there are little clues and things that are in Python, which is why I used to love it, using it with my young people when I was moving them on from Scratch into Python. So it's, as it says on the screen for you, it's an object-oriented programming language. It's really versatile. It's used for creative projects, and it's also used in like huge rollouts. So for example, many of you will be familiar with CMIS. So CMIS is run is scripted through Python. That's the program that the company that makes CMIS use. So again, it's widespread, it's out there, and it's really, really flexible and versatile. So with that, there's a lot of tools that we can use it with, like I was speaking about. So obviously we're moving on from our original application, so maybe the Codepillar app or physical devices, right through to we can still use familiar products like the microbit or mini drones, lots of different products such as that. And these can be used with block-based coding. But again, when you're starting to look at next level, you can start to introduce Python with these products too. So if you would like to join in with Lorna's presentation, just before we move on, if you have a different screen or an iPad or a device available to you, you can go to the web address, so jump2.cc/Python new. So that will then let you join in alongside us today. So if you want to join in, that would be great. This presentation is also already in the file space and it's all hyperlinked up. Moving on as well, if you do want to install it or download Python or you want to speak to your local authority about it, this is the website here and we'll revisit that at the end of the session too. But essentially, if you do want to join in, it's this address that you will need. Okay, so it doesn't matter what device you're using and it's a very flexible tool. So with that, I'm going to hand over to Lorna, and Lorna's going to talk to you about CodeClub and the fact as well that Lorna will speak about CodeClub, but I would just like to emphasise that these resources can be used remotely, so you can share out a project in your team, Google Classroom, and it can also be part of your core curriculum work that you're using. So whilst you might have had an out with the school day CodeClub previously, we would definitely be encouraging you to use this to support the computing science side of the curriculum. Either working remotely with blended learning applications, whatever format learning is looking like at the moment. Okay, Lorna, over to you.
Jenny, could you put the link up again, please, before you stop sharing your slide?
Of course. There we go.
Thank you. Just give it 10 seconds just for folk to copy it. Right, I think that should be okay now. Thanks, Jenny.
No problem. Okay, Lorna, over to you.
Thank you, Jenny, and thanks everybody for joining me today. So I'm going to give you a very quick whistle-stop tour of what CodeClub is. So CodeClub is an international network of free coding clubs around the world, typically aimed at young people aged between 9 and 13, but nothing about CodeClub is prescriptive. So I certainly have used the coding projects that I'm going to show you shortly with people out with those age ranges. Obviously, the younger age under 9 years, it's more a literacy thing. So if they're a confident and competent reader, they'll get on absolutely fine. We have the ambition to inspire the next generation to be excited about computing and digital making. We typically run or had typically in the before coronavirus world, were an enrichment extracurricular activity. So we'd run as a lunchtime club or an after school club, or some places as a breakfast club. That said, we had lots and lots of people using our resources within the classroom. And while it's probably not clear on the web page as it stands at the moment, all of our projects are free and open source. So if anybody can make use of them, I think that's great and is absolutely fine. So if you feel an opportunity to use some of the projects at some point during curriculum time, don't be put off by anything that's on the website that suggests otherwise. We will update that, but yeah, go for it. Next slide, please, Jenny. There we go. So just a very, very quick note, just because when you come to the website, you'll see some things that it's worth clarifying. So CodeClub is one of the larger educational arms of the Raspberry Pi Foundation. So Raspberry Pi, for anybody who doesn't know, is that small microcomputer there you can see on the left-hand side of the high-fiving robots. It's about the size of a credit card. It's a low-cost priced bit of computing equipment. There's a foundation that sits around that. CodeClub is one of the education arms for that. But that said, you do not need to have a Raspberry Pi or be in possession of a Raspberry Pi, use a Raspberry Pi to take part in CodeClub. CodeClub is completely device neutral, so pretty much as long as you've got a device and access to the internet, you can access everything that you would need to for a CodeClub. Next slide, Jenny. So I am going to take control of the screen, so bear with me for a second. Make sure that I'm doing the right one. Okay, so I should be screen sharing any moment.
Yep, that's you.
That's me, perfect. So if you go to Google or your search provider, search engine of choice, and type in CodeClub project, you will normally land at this page. And if you were with us a couple of weeks ago, then this page will be familiar. As a quick run through, there's various different projects. We looked at some Scratch a couple of weeks ago. There is some HTML and CSS, which is web programming kind of stuff. But today we're going to look at Python. There's also some other materials there further down. We're going to look at Python, and I was actually going to be looking at doing, so all of the CodeClub projects are broken into 6 projects in a module, and if you're signed up with CodeClub, you have access to certificates. So once a young learner has completed 6 projects, you can send them through a certificate to say they've completed that level. At the moment, I've got 2 kids at home learning at the moment. The 8-year-old has recently read a book called Mickey and the Animal Spies, which is all about codes and ciphers and secret messages. So we've been doing a lot of that. So I was intending on doing the secret messages, but we did so many codes and secret ciphers yesterday. I am going to have some fun with you today, and we're going to race some turtles because I'm in Northeast Fife. It's not very sunny, and so I need something bright and engaging. So these are the projects. We click on Turtle Race. And what happens on all of the CodeClub projects is on the first page, there's always a working example of what you're aiming to make. So all the young learners can see what they're aiming for by the end of the session. So this one, we're drawing a racetrack, and then we have 4 turtles that are going to race on the racetrack, which is all very exciting. As you scroll further down, there's information there that you might want to know in terms of what learning intentions are with the different projects, where it sits within, the digital making curriculum that the Raspberry Pi Foundation has set up in terms of those kind of things. But mostly we have a look, we see what the project is, and then we skip to the next thing. So for this project, I'm going to skip again because I want this link. So there's different ways that you can program with Python. Most of the projects with CodeClub, in the same way as Scratch, you can do online. We have an online version of coding in Python using something called Trinket, which has got all of my things from earlier on. So let me just clear that. So you can click on the link, and what normally happens is that's not all normally there. I think I've still got it open in the background somewhere. So I'm going to take that out so we can have these 2 things next to each other, and we're going to put that one there. I'm going to try and find what I did with the other one. Bear with me for a second. Don't look at all the million things that I have open at the moment. There we go. And we can have that one next to it. There we go. So in the same way as Scratch, where you could write some code on one hand of the screen and you could see the output on the other, this happens with Trinket as well. And if you were interested in using the HTML and CSS, you can have those things parallel within the browser using Trinket. So where we are now. So we've opened the template. The template always starts with that green bin line. We don't need to do anything with that. And then it's just a case, similar to the Scratch stuff, is going through the instructions. So the first thing I'm going to do is, I'm going to make sure I'm in the right screen. two screens next to each other. So I'm going to say from turtle import, and then the star means all. So basically what's nice about, so often when I'm introducing young people at the Code Club that I support, at the school that I support, moving on to Python can feel like a bit of a big jump because they have to, Scratch was drag and drop, click together, Lego style coding. Nothing could go wrong. Sometimes things didn't work out how they were expecting, but it never failed. Once you move on to Python, it's much more specific. However, the young people that I have spent time with tend to get excited knowing, as Jenny said, that this is a real development language. This is a real thing that real live coders use. There are all sorts of examples from when I've been out to visit code clubs and chatting to teachers about how much value and how much excitement young people can get when they see I've got the code on one side of my screen, that's the working code, and the code on the other side, which is the code I've typed in, isn't working, and playing a bit of spot the difference, trying to work out what's missing. And later on we'll have a couple of examples of where things have gone wrong. And there was a lovely example from a club I visited late last year where there was a young boy, a primary 7 in the class, who came over and said, "Miss, now I know why you're telling me punctuation is important, because if you miss a bit of punctuation in code, the computer doesn't know what to do." So there was a nice learning opportunity there. So what happens on that first line? Basically, in formal coding environments, there's all sorts of libraries, so we don't have to write every single line of code. So this library here is giving us access to the turtles that we can use later on. So we're importing the turtle, and then we're just going to write forward 100. So in the same as in Scratch, where we have move 10 steps, we've got go forward, and then we can press run and see what happens. So we've drawn a line. We can then go down to the next stage here. So this one we can see on the image, we're going to put some numbers on the line. So I can add in front of that. So I'm going to say write 0. I'm going to go forward, and then I'm going to write 5. And whatever's in the brackets, 50, maybe not 50. Whatever's in the brackets is what it's going to write. So we'll give that a test again. And now we've got our arrow, our line, with a 0 and a 5. Okay? So the next step is we could write all of these lines to make what's here, whereas it's an arrow with the numbers 0, 1, 2, 3, 4, and 5. Often what happens if you have done some Scratch coding already, and young people are familiar with the idea of repetition and being able to put things in loops to avoid having to do repetition, they'll already jump themselves to the next step by going, well, actually, that's just the same thing more or less over and over again. How can I do this in a sleeker algorithm? So we're going to skip to that next. Oh, sorry.
Sorry to interrupt. Can you maybe make your trinket page just slightly larger?
Yeah, absolutely.
It could just be my slightly rubbish eyesight, but just to maybe help anybody who's joining along.
Is that a bit better?
A little bit, yeah.
Which side is harder to read?
It's just the size of the font, but so I don't know if it's feasible to zoom in a little bit, but maybe not. Don't worry.
I don't know.
That's okay. Don't worry.
Okay. So what we've got, we're going to skip typing all of that out. We've got places to be, places to go. So we are going to add a loop. So the loops essentially are similar to that they would be familiar with from Scratch. So this is a for loop. So they know they've already started right because the words that the computer knows definitely what to do with change colour. So we're going to say for step in, and we're going to say we've got a range. So our range is going to be 5. And we'll remember the full colon at the end. And this is where it's similar to Scratch, where we had those arms in the loop that would go around and hug it. We need to remember to indent, and this is the most likely debugging problem is a missing indentation. So that looks like, and I need to change right to step, because in that for loop it's going to do for step, and step will be a number, move forward, move forward. In fact, it's easier if I just show you. Sorry, I'm thinking about how to change the font size, and now somehow, without knowing how to do that, I have managed to change the size on that side.
We also have a suggestion from Miss Mutter. So it's under the 3 lines in the top left, you can increase the font size of your trinket.
On the 3 lines here?
So under the 3 lines in the top left, you can increase,
Wow, there you go.
Oh, thank you so much.
I've managed to kill the bit on the right hand side now. What have I done now? So it is made. Let me run that again. We should be able to see it all, but it's now run off the screen, and I don't quite know why it's done that. Okay, we'll persevere at the moment, and hopefully it'll be happy in a second. So we've done a range. In fact, that doesn't help us at all because we need to see the range. Why has that done that? Oh, drat. Right, I'm going to just refresh the screen for a second, and I can change the size back on here. Okay, and then let me just very quickly see how fast I can type. It would be ideal if you could see the whole part of my screen on the other side. So we've got right, step, and then forward. I think actually I didn't change. I had forward 20, which was probably actually a typo on my part. It was. So I think earlier on we had forward 100 and I didn't change the word. So it was nothing to do with the computer, completely user error. And I didn't do the spot the difference to work it out. Okay, so what happened here is we want a range of, we've said we want a range of 5. What we're aiming for, if we look at the screen here, is we were aiming for it to go up to number 5, and mine hasn't. And that's because when a computer counts, in coding when you're counting, it always starts as 0 being the first number. So if we change that range to 6 and run it again, then we get all the way up to 5, which is what we're looking for. Perfect. So we've written just a few lines of code, and we've started to map out our racetrack for our turtles. So if we go down to the next step, I haven't scrolled down anyway. So now I would like to start adding in a turtle, because we really can't, well, maybe I should finish building my racetrack first. Okay, we'll do that. So what we can see here is actually we're going to want to start a certain set of coordinates. So if you've done any coding with Scratch, you'll know that the center of the computer screen, imagine your X and your Y, the center of this computer screen is 0, 0. And really helpfully in Scratch, as you move around a character, you can see the character's coordinates change. We can't do that on Python, but we do know that 0, 0 is the center of the screen. And the code here has given me an example of what we want to do. So we are going to go for our X coordinate being at minus 140 and our Y coordinate being at 140. And we can have a look and see what that does on the screen. So that's just moving it up so that our race is not starting in the middle of the screen. We're actually moving it up so we've got plenty of space, because we might build a slightly bigger racetrack later on. Rather unfortunately, because everything always starts at 0, 0, which is the center of my screen, it's drawn this unnecessary line. So what we can do to stop that from happening is just saying lift the pen up, because I don't want you to draw right now. So if you lift the pen up now, you can see that the little arrow moves, but it doesn't actually draw that line across the way. Okay, so the next thing that we want to do is we want to draw, the easiest way to judge a race is to have some sort of finish line, but also maybe some lines to see where people are along the way. So we're going to start drawing some vertical lines now. So we've still got the same for loop, we've still got the right step, but this time we're going to give it some directional advice. So we're asking the cursor, the arrow that we're controlling, to turn by 90 degrees. And we're going to ask it to go forward by 10. We're going to get it to put pen down. So that first step actually is just giving it a little bit of a break away from the numbers. When we did it before, the arrow was very close to the numbers. It was difficult to read. So that first bit is just to make it a bit neater. We're going to put the pen down, ready to draw a line. We're going to go forward by 150. Then we're going to lift the pen up again because we want to stop drawing. We want to go back up to the start, so we're going to reverse our instructions, so go backwards by 160 because we have the 150 and the 10. So that one and that one, so that's why it's 160. Then we're going to go left because we're going to move under the next number. And we're going to turn back to face the right way, move forward so that we get under the right number. And this is one where spinning it verbally is quite tricky, but as you play with some of the numbers, you can see how it changes. So if we run it now, first thing there is there's an error. And it tells you a little bit at the bottom. There's some useful information sometimes. Sometimes it's a bit trickier. Sometimes the first line the error is on doesn't mean that the error is there. It means it's often just before that. That's the first point it's got stuck. And it's basically on purpose, of course. I add an extra letter just to show how specific we need to be with Trinket. So it knows what to do with forward, but it doesn't know what to do with forward. So now we're drawing our lines underneath those numbers. Okay, what we can do if we're feeling a little bit inclined to make it look a bit neater is the numbers are a bit offset, so that's not great. So we can align those numbers to be in the center. Now this is American spelling on this coding, which is worth pointing out. So now the numbers are sitting a bit neater on those lines. But it's also taking a little bit of a while to draw that. So I'm going to go right back up to the start, almost at the beginning of my code, and I'm going to set the speed to 10. Oops, to 1 will be very fast. We'll set it to 10 and we'll see that it's just a little bit quicker. Because as you keep adding bits of lines of code, you don't want these things to take a long time to do. So we've made the course for our race. Okay, so we're ready for the next page. Next page, what happens often with our project materials is there'll be the occasional challenge to extend or further the learning. This one, the challenge is, could we make it a longer course? So we want it to go from 0 to 14, which is possible for us. So we could do, what often happens is young people will put the 14 in there and they'll test it out. And then once they've tested it out, they will remember that actually, yes, it starts at 0. So that only takes me to 13. So I need to change that to 15. That's a good way to consolidate that learning. And then it's also telling you now that it's a longer course, actually, that's still taking a little bit of a time to build. So we could go back up to our speed setting and we could set that to 0 to make it super fast. And so we've actually already completed the challenge on that one. So we've got our race course. So the next thing we need is we need our turtles. We need our racing turtles. So we're going to add some code after our race course has been built. The first turtle we're going to name Ada because obviously, Ada Lovelace, very important computing person. So we're going to make Ada equal to turtle, which is something that already exists. So we've imported all sorts of turtle information up here. So we can make Ada a turtle just by that one line of code. We don't have to do anything else. Then we can change Ada's color. Again, watch the spelling on color. And we're going to make Ada red. A red turtle is a good turtle. And there's all sorts of other shapes that we could explore, but we're just going to make sure, that it's a red turtle for this race. So we've given Ada all sorts of controls with that first line. We've made the colour and we've definitely declared that she's going to be a turtle. And so if we press run, then we build our race course really quickly and we've got a turtle. It's a pretty fast turtle because she's already at number 7 on the race course. So we need to think about making sure, in the same way as we changed where the race course started, we need to think about moving the turtle to be at the start of the race. We don't want her to draw a line over the course, so we need to make sure we lift the pen up. And then we're going to say Ada is going to go to, again, helpfully we've got some XY coordinates for us to use there. And then when we say Ada pen down, that will make her appear there. So Ada pen down. Ooh. Let's have a quick test. So Ada should, there you go. So Ada moves. She doesn't draw a line, but you see her move into position. She's on the starting line and she's ready to go, which is brilliant. But we haven't got Ada moving yet. And if it's going to be a race, we don't want it to be a fixed race. We want it to be a randomly generated one. So back at the top, when we called in this library, the from turtle library, and brought all the information in, there is another very helpful library for this instance, which is called the random library. So that allows us to generate random numbers without having to do anything more than 1 or 2 lines of code. So from the random library, we're going to import the random integer, so the random number part. So that's great. So we've added that at the top because we want to bring all the bits of code in right at the start and keep that all neatly together. And then we're going to go right back down to the bottom where we were giving Ada some information, and we're going to do another loop. So we're going to do a for loop. This one's going to be called turn. So for turn in a range of 100. And it's okay if you don't exactly know what all of this does, because you can experiment and change things, and that helps you learn what the different functions are. But we're going to move Ada forward at a random number, so we call random integer, and between 1 and 5, because we don't want her to leap forward, but that's a range, that range you can control, and you can experiment with too. And I've certainly seen lots of young people have fun working out whether within the first move can you get the turtle to leap across and win the race. So let's have a quick look. So we're building our race, we're putting our turtle there, and she is moving at a random pace. Difficult to tell with just one turtle there. You might see her stop and start slightly, but it will be much easier once we add a different one. So we're going to add another turtle. Okay, very helpfully we can do that by just doing a bit of copy and paste. So we can go add one in here, and we're going to change all the Adas to another good 3-letter name. So we're going to have Bob. So Bob is going to be a blue turtle. We do need to change the colour, or it'll be 2 red turtles chasing each other. Change that one to Bob, that one to Bob, that one to Bob, and that one to Bob. Now Bob at the moment is going to start at the same place, and we don't really want them to be at the same place. We want the race to have lanes like a typical race. So we're going to take 7, we're going to, there's an example here, which is same X coordinate, obviously, and move the Y coordinate down by 30 and move it to 70. And we can experiment and see if that's quite how we want it to look. But let's give it a wee look. So we've got Ada and we've got Bob. Brilliant. Bob didn't do anything though, he just sat there. So we do need to give Bob a little bit of encouragement and give him some code. So we can just add into the very same for loop. We don't need to have another loop. We can just add another line which says in this loop, so at the same time, we want Bob also to move randomly. So if you give that one a try, we've got Ada, we've got Bob. Oh, so you can see they're not quite moving at the same pace. Ada won that time. We run it again. Will it be Bob's lucky time? No, Ada's stomping away. We give it one last time. The whole issue with random numbers is, Bob was doing well, but Ada does seem to be the fastest turtle in the West. So we've managed to add 2 turtles. So that's everything that we required on that page. We've got another challenge coming up.
Lorna, before you proceed, can I ask a question that's coming from Gemma?
Absolutely.
She's asking, is there a way to overlay have an overlay of the coordinates? So you know how you can put an image on Python. Is there a way to overlay the coordinates for maybe younger learners?
Great question. I don't actually know. Quite possibly. I mean, we used to do that sometimes before the more recent version of Scratch. We had an image that had the coordinates on it that we would put in the background of Scratch to help people identify where they wanted to position things. So I'd imagine we could do the same thing. I just haven't seen anybody do that, but I'm more than happy to have a little experiment offline and ask the learning team here and come back with an answer if that helps.
Yeah, that would be great. Thank you. That's super. I'll. Miss Gemma's saying thank you.
Brilliant. Sorry, I should have put the chat bit up at the same time, but I can't do that now. Right. So the challenge was to add some more turtles, which, because of the power of amazing cut and paste, we can do quite easily. So again, we'll add another turtle now. Thinking of another 3-lettered name just on a roll, so that should have been Joe. So Joe is going to be, what colour Joe can be? Joe can be green. Green turtle, probably more of a typical turtle colour. We already, when we do this bit, actually we'll just add Joe in there before I forget. When we're trying to think about the starting place for Joe, what often happens is we look at the starting place for Ada had a Y coordinate of 100, and that then Bob went down to 70, which was a good distance. So they work out the difference of that is 30. So then they go down and go, well, if we take 30 from 70 and try 40, let's see what happens. Which is great to see them spot those patterns. So now we've got a green turtle. Ada seems to be, I haven't pre-programmed Ada just because she's a female, amazing computer scientist from history, but she seems to be doing particularly well on the races today. So without any particularly new code, just repeating the code that we've already learned. Oh, that was a closer race. We've managed to get 3 turtles, and if we very quickly just add a 4th one for fun, this of Sam, and just to prove that we can. And again, in the last group that was doing this with me, then turned that into 10 because they were going down in blocks of 30, which was great. So we've got Sam at the moment is the same colour, which would be a disaster. So let's try yellow. We should have 4 turtles now. Oh, yellow's quite a hideous colour, isn't it? So can hardly see the yellow turtle. It's incognito. Let's change that to orange, see if that shows up a little bit better. There we go. And we've got orange. And we might even, yeah, Ada's still doing pretty well. No idea why that's happening. And then you can experiment with all different kinds of colours. You can make your race course bigger and have more turtles racing. You know, sometimes there's a little bit of fixing that goes on if somebody has a favourite colour. So the random integer number, the range for the random integer changes so that one of them is always going to win. So spot that if you're asked to test out any games. That's always a good one. And then there's a series of other challenges which we don't need to look at. But they're always given a bit of a hint about what they might want to do. So there's a challenge where you can get the turtle to do a little 360 at the start. So, you know, at the beginning of the race, wave to the audience, be excited. And then another challenge where you can have dotted lines rather than straight lines. And that's essentially one of the Python projects. So if I just go back for a second, that's the actual third project in the first Python module. So they will already have done a bit of ASCII art at the beginning. There's a game, a rock, paper, scissors game. So they'll have learnt a few bits of, a few Python skills before they get to that. And then they have an opportunity to move on and ultimately work towards the secret messages, which is using kind of a number substitution cipher to encrypt messages and allow you to send them to your partner and say whatever you like. So that's a bit of a whistle-stop tour with Python. It can be quite tricky because, like you saw, you know, various spelling mistakes require, if you miss the semicolon and you try and run it, you know, there's a problem there. So in this instance, the feedback given to the user is not great. It says it's a syntax error, bad input, doesn't, you know, not like the last one where it said it didn't understand the word forward. So this is where the young person would be encouraged to look at, well, what does your code say and what does the code example say? And then go back and forward and try and spot what the difference is. Invariably, they learn quite quickly that the first thing they do is go through and check that all their semicolons, their full colons are in the right place, because it does become it's an easy thing to overlook. Jenny, is there any other questions?
No, nothing else has come in so far. No, I don't think anything else has come in.
It's a bit of a whistle-stop tour, and I think the one thing about Python, because it's not as visual, you know, dragging and dropping and clicking together the bricks in Scratch, it is one to play with and to experiment and to try things out, you know, but actually, you know, can be incredibly rewarding for the young person, particularly if there's been, you know, some, you know, if it's not quite worked or there's been a little bit of an error and they've gone back and forward and meticulously played spot the difference and identified what the problem is. There's an immense sense of satisfaction, and when they know that they're coding in a language that, you know, people are using within the real world context within, you know, various industries, you know, you do see their shoulders lift, them sit a bit taller, yeah, it's fun to watch them do. So often in the club that I support, it's kind of primary 6 and primary 7s that have a try with Python and do well. So I hope you have a chance to explore it. There we go.
So there's a few comments coming. So Mrs. Afrin and also Miss Sanderson have said that there's articles in Hello World, which again, and Miss Afrin's put a link in the conversation space, so if you don't already subscribe to Hello World, it's definitely worth having a look at. And there's some projects in there, and Miss Sanderson's saying there's a bit about edu-blocks. So again, that's great. Mrs. Mitchell, do kids need to do BIBOTs prior to using Python? BIBOTs? I'm not sure. Lorna?
BIBOTs.
BIBOTs. Sorry, Ms. Mitchell. Yes. Thank you, thank you, Ashley. So, Lorna, I would say no.
No.
So for me, in my practice, I used BIBOTs as an introduction to directional language, creating an algorithm, so, you know, linking that back to computational thinking, and them understanding what an algorithm is, so that when they use programs like Scratch Junior, that wasn't a thing when I was doing this, but Scratch, when I was introducing that from the BIBOTs, that allowed them to see they had to create the algorithm, and that was essentially what they were doing with the building blocks in Scratch. And Python and the other projects that are beyond Scratch in CodeClub do have a really nice way of progressing young people through, as Lorna's demonstrated, with scaffolding there, you know, for practitioners as well as pupils. That is really useful. Lorna, do you have anything you want to add into that?
Yeah, no, I mean, I think the BIBOTs are great, but you don't need to have to use them in terms of understanding the kind of the word that I can't say, but I've now put into a sentence, the specificity of, you know, being purposeful with the words that you use. I've seen lots of class teachers, you know, use a gym hall and ask one child to be blindfolded, you know, with mats on the floor, and, you know, have to just follow the instructions given to them, and the other person has to give the very specific instructions to move across the grid to get to a certain place. So it's a really kind of physical kind of stuff, just to get the idea that if you don't say turn left, you know, nobody's going to do that for you. The computer's not going to understand that you need to do that. Just to jump back to the Hello World, just because we didn't say, Hello World is actually free for teachers. So when we talk about a subscription, you can just go to the website and sign up, and you can either look at the online copy, or you can have one delivered to you every time that there's one out. And if any of you are sitting on any amazing things that you're doing in class in the broader sense of computational thinking, digital skills, all of those things, and would like to share, because most of, you know, it's written for educators by educators. If you have something that you would like to share, I'd love to see some more Scottish content, and, you know, you're very, very welcome to reach out to me if you'd like me to make an introduction to the team, because you have, you know, an example. Even, you know, as you'll see when you look at the magazine, you know, some of them are kind of very much a lesson plan example of, this was the intention, this is what we did, here's some pictures to go along with it. So yeah, if there's anybody sitting on a thing, I would strongly encourage you to get in touch.
No, that's great. And please, as you'll know, Did You Learn Scott's got a blog, but, you know, please celebrate what you're doing. And also that unplugged activity where Lorna is speaking about young people guiding each other around gym halls and things, that's an activity that can be shared whilst young people are at home as well just now. So, you know, they could ask a family member, or they could write a program for themselves that they can follow, and they can be the Bebo, or they could be the robot, or whatever you want. And I've done that in school with like t-shirts, or I've seen it done with tabards and all sorts of things. So and Mrs. Hughes is just saying Barefoot Computing has some really simple algorithm activities. And yeah, and we did a webinar last week on Barefoot, which is hopefully going to be put in our YouTube channel soon. So yeah, that's great, Mrs. Hughes, and please have a look at Barefoot Computing. Lorna's a big advocate for them as well. Okay, so we've looked at computing science within the technologies, and we've done a little overview of CodeClub, what it is, how you can maybe use it in the current situation where our pupils are maybe not with us, but also moving forward. And Lorna's demonstrated how we use, how to use a Python project, what that looks like. So that leaves for me to speak about some next steps in help and support. So if you want to go to CodeClub, again, this presentation is already in the files space of our team. It's in the presentation folder. And it's all hyperlinked up. So you can go to the CodeClub website, you can see the training and events pages that are there. There's some CLPL that's available for staff. Again, it's free, it's online, and there are some home activities which are fantastic that you can share out with your young people at home. So check out their website. Just to reiterate, if you did want to look at Python in more depth, Python's website is again linked here. There's some information, there's guides, there's documents, and there is a whole set of information that's available. That's also where you can go to download it as well. Lorna shared some key links to the different projects that are available. The digital making at home resources are fantastic. It's worth having a look at them if you haven't perhaps already. And if you do want to run an event online, there's a really good guide there from Raspberry Pi Foundation. And also, whilst it's designed for the English curriculum, the Teach Computing resources are also perhaps worth a look if you have time at the moment. We would also encourage you to please take a look at the technologies community within Glow. We post a lot of information there. We've got links to different organisations and we've got resources. This is the computing science page, but again, there's one for digital literacy, so it's about all the technologies there. So please take a look and see if there's anything there. If you've got any suggestions of what you would like to see there, again, we're really keen to hear from anybody with suggestions too. Python, Scratch, computing science generally, there's a huge wealth of online resources available to you. These are just some of them. As we've mentioned, CodeClub is there, but Microbit's site has varying degrees of difficulty within terms of the projects that they have available. So does Hour of Code, so we would suggest that you maybe check those out if you haven't had a chance to take a look. But these are activities that can be again used in the current situation, perhaps when we have a more blended week, when we start back again in August, or even for your own professional development, if you want to take a look and maybe try some out, they're lots of fun. And we are running additional webinars, so anything that has been put on by our session, we generally try and record them. Our last CodeClub, the person that was recording it had a bit of a Wi-Fi issue, so Lauren and I are going to re-record a little snippet of it, and then that should be up. So if you were new to coding last week and using CodeClub materials, that webinar is going to be on our YouTube channel. But if you do want to go to any of our resources, our blog, which is at the left side of the screen, takes you to our YouTube videos that have been recorded of our webinars, and there's also a webinars tab that lets you see new resources that are available. And we've also then got our blog. So as Lorna was saying, Hello World is a fantastic way to get your projects known and the work that you're doing known nationally, and I think internationally as well. That like Hello World is a fantastic magazine, but you can also share our your work in our blog, and we would love to hear from some guest bloggers too. So that just leaves me, I knew my laptop was going to stop presenting, so that just leaves me to say thank you so much for joining us today. If you have any other questions, please pop them in the chat. My colleague Susan, who is on this call and is filming the session, has popped in our evaluation. The YouTube channel is DigiLearn Scott. The easiest way to find it is via the blog, if you basically go there, but also there is a link in the evaluation that Susan has pasted a link to in this chat. Lorna's Twitter feed is CodeClub Scott. Oh, sorry, Lorna, I'll change that. So please feel free to get in touch with her. She's always sharing lots of great work that she's doing, projects that are coming up, AstroPi, lots of different things that are available. And if you are doing anything, please hashtag DigiLearnScott. Okay.
And I was just going to, I put a quick comment in the chat, but when we mentioned digital making at home, I spoke about it during the Scratch session, but I forgot to speak about it during this session, and basically it is a series of code-along videos by educators within the foundation. There's a different theme every week. There's 3 videos that come out, and so how I know some teachers have been using it at the moment is actually sending home one of the videos or just sending home the page that points to all of them in the school newsletter. So it's particularly good for anybody who needs a little bit further scaffolding from the worksheets, if they would cope better, if they'd be engaged with coding but would cope better with a video that kind of similar to today's session, just talk them through each step, then that's there, and that again is free for anybody to use and access. So.
Thank you all so much for your time. If you don't have any more questions, please feel free to leave the call. You can do that by the red button. If you do have anything you want to ask, please feel free again. We're still here, so pop that in the conversation space. But when you're ready, please use the red button to hang up the call. If you're on an iPad, it's at the bottom of your screen. If you're on a laptop or PC, if you just hover in the centre of your screen, you'll see it appear there for you. Thank you all so much. And as I say, this has been recorded, so you can check it out, and the presentation is already in the file space. Thank you. Thank you, Lorna. Thank you, Susan.
Thanks both.